Okay, so today now we will, after discussing the sum of the linear application and the sum of the non-linear application of the operational amplifier, today we will going to discuss a very important topic of the operational amplifier that is also be studied in the 555 timer also, but it can be implemented in the using the operational amplifier. So the topic of discussion today is the Schmitt trigger. Okay. Those who have studied the analog electronic must have heard the name the Schmitt trigger. Okay, now we are going to discuss the inverting Schmitt trigger here. That means the input is going to be given at the inverting terminal. Now in the case of the Schmitt trigger, first I am drawing the circuit, but in the case of the operational amplifier we have discussed two kind of feedback, not two kind of feedback, two kind of configuration. First configuration is your open loop configuration. Now in the case of the open loop configuration, all of you know that if we connect the op-amp like this, so this is another input, this is another input, this is the output, and this is the plus V and the minus V. Two supply voltages is given and no feedback is given. Here is no feedback. If no feedback is given into the circuit, then what we expect is that if this terminal voltage is higher than this terminal voltage, then the output will go to minus V saturation voltage. And if this terminal voltage, okay, if this terminal voltage is higher than this terminal voltage, the output is go to plus V saturation. That means output will switch between the plus V sat and minus V sat. Okay, and in this configuration, operational amplifier will no longer be act as an amplifier. So this is the case we have discussed previously. And also there is another configuration. That configuration is the closed loop. So there is another type of configuration. That configuration is called the closed loop configuration. Now in this closed loop configuration, what you can see is that this is the circuit. That means input is given to the negative terminal and this terminal is being grounded, and this is a feedback resistance. In this case the output voltage is given as V0 equal to minus R2 divided by R1 into V1. Okay, so this is the expression for the this circuit, and this circuit can be used as an amplifier. Okay, and one more thing about that negative feedback is been given to this circuit, provided there is a closed loop configuration and the negative feedback. If there is a negative feedback, that means the circuit is in a closed loop configuration. So if these two conditions is being satisfied, then the operational amplifier can be used as an amplifier, very good amplifier. But the only one disadvantage is that the output voltage, though it can be used as a very good amplifier, the output voltage cannot exceed plus V sat or the minus V sat. That is the one disadvantages of using the So one disadvantage is that the output voltage cannot exceed the plus V sat or the minus V sat. Okay, but other than that, this operational amplifier in the closed loop configuration and with the negative feedback can be used as an amplifier. Now one more thing is there. Instead of connecting the feedback to the negative terminal, if we connect the feedback to the positive terminal, so instead of connecting the feedback to the negative terminal, if we connect the feedback to the positive terminal, this thing can also happen. This condition can also happen. That means output is going to oscillate between the plus V sat and the minus V sat. Okay, so that the case we are going to discuss here. And this circuit, positive feedback circuit can be this positive feedback circuit can be used as an oscillator. Okay, this circuit can be used as an oscillator, but we will not discuss the oscillator circuit here. We are discuss a special kind of circuit that can also be implemented using the 555 timer also, but we will not discuss here the circuit Schmitt trigger circuit using the 555 timer. We will discuss the Schmitt trigger circuit using the operational amplifier. Okay, so that is our main agenda today. So first we will draw the circuit. First we will draw the circuit, and next we will discuss the input and the output waveform and also the transfer characteristics of this circuit. So this is the circuit diagram. First I am drawing the circuit diagram. So this is the negative, this is the positive terminal. Input is given to the, this is the V input. Input is given to the negative terminal, and as expected the output. Okay, so this is the one resistance connected to ground. Okay, and there is a feedback path. this feedback path is going to connected to the positive terminal. So this is the output voltage, and there is a resistance value, and you can see very well easily that the output voltage is going to feedback to the positive terminal. So that is our main interest, that the output voltage is feedback to the positive terminal. So that's why it is a positive feedback circuit. So that's why output voltage is going to oscillate between the plus B sat and the minus B sat. Okay, now if this resistance is R1 and R2, we can consider this resistance and R1 and R2 and this point potential at X. So this is a potential X, and suppose the plus B sat voltage is plus 5 volt. I am just considering different type of value here, so that our discussion will be easy. So this value is be minus 4 volt and this value is be plus 5 volt. So this plus V and the minus V can be different, it can be different. Okay, and instead of a simple understanding, so this point potential is X, so this potential is also, this is the potential also here at this terminal. Okay, and the input voltage I am considering here, the input voltage. So the input voltage is going to be a sinusoidal voltage. Okay, so this is the sinusoidal voltage and this is the output voltage we are going to draw. This is the output voltage we are going to draw. Okay, so this is the input voltage. So maximum value of this value is, that means the input voltage is 10 sin omega t. Suppose the input voltage is 10 sin omega t. If this is 10 sin omega t, so this value is your 10 and this value is your minus 10. Okay, so this is the two value, and also this is your time t, this is your time t, and okay, and for the our simplicity purpose we have assumed that this resistance is 2k and this resistance is your 3k value. Okay, so this is the circuit, and in the book you will encounter this resistance is R1, this resistance is R2, like that, but for the purpose of understanding we are assuming that this resistance is of value 2k and this resistance is value 3k. So this circuit is clear. Hope this circuit is clear to is this input voltage is nothing but this voltage, a sinusoidal voltage 10 sin omega t. Okay, 10 sin omega t. This is an input voltage gain applied, and this is the output voltage that we will study how the output voltage will going to vary with the input voltage. Okay, so first assume that this X value initially, now what is this value X, what is this voltage going to appear here? Suppose this voltage is X, so this X, this voltage is across the 2k terminal. So this is the voltage divider, output voltage is going to appear here. So this is simply a voltage divider, that means this one resistance here, one resistance here, and this we are going to calculate the X. So X is nothing but your V0, this is V0, this voltage is going to divide between these two resistances, and we are going to calculate the voltage across this 2k resistance. Okay, so this 2k, V0 into 2 divided by 2 plus 3, so 2 V0 divided by 5. So this is the output voltage, that means the X voltage at the positive terminal that we are going to calculate. So okay, so if initially we are going to assume that the X is equal to 0, that means the potential is this point is equal to 0. Initially we are going to assuming that. So initially X is equal to 0, and also so positive terminal potential is 0 volt, and the negative terminal potential is if going to increase. Suppose this negative terminal potential is going to increase from 0, so somehow it has become some amount of positive voltage, a very amount of, so input voltage is going to increase like that. So from 0 if it is going to start increasing towards the positive, that means this negative terminal voltage is going to become positive. So this terminal voltage is higher than this terminal voltage, so output is initially switched to minus b set. That is the case, the output will initially switch to minus b set. So this is the first, the initial condition, that will not happen again but first time. So we are considering this is plus 5 and this is minus 4 in this case. So output will initially going to minus 4. Okay. Next what happens, suppose as well as this voltage is 0 volt and this voltage is initially going to minus 4. Now as well as this voltage is minus 4, as this voltage is minus 4, okay, then what happens, this whole condition will change. So I'm just removing all this. So x is no longer be 0. So this voltage is minus 4, so 2 into minus 4 divided by 5. So the output will this potential x will change as long as well as this voltage is minus 4, this x is going to change minus 1.6 volt, minus 1.6 volt. So this negative terminal voltage is going to increasing in this fashion, going to increase in this fashion, and this negative terminal voltage, this positive terminal voltage is minus 1.6 volt. So as long as you can see this is minus 1.6 volt, this is a voltage fixed. So as long as this voltage is higher, this positive negative terminal voltage, this negative terminal voltage is the input voltage, this is minus 1.6. so this is your minus 1.6. okay, so as long as your input is higher than this minus 1.6, then your output will be minus b set. So in that condition, up to this, your output will be minus b set. Hope you understand this. First I am again repeating this. First, initially we have considered x equal to 0. So as this x equal to 0, output voltage is going to minus 4. This is the initial case going to happen. Okay, after that what happens is output is minus 4, your x will switch back to minus 1.6. so this is the reference point has been here. So this is the reference point, minus 1.6. so as long as your input means negative terminal voltage is higher than this minus 1.6, then your output will be at minus 4. So what happens after that, it crosses the minus 1.6 level, then what happens, this point potential will be higher than this point potential because input is going below minus 1.6. then what happens, output will switches back to plus b set. So output will switches back to plus b set. So how long will maintain is plus b set? So as long as this voltage is become plus 5, voltage plus 5, then what happens, again I am just removing this. As long as this become output voltage is become plus 5, then what happens, output voltage is becoming 2 volt. So there is again a reference, this is your, suppose this is your 2 volt. So this is your output is again increasing in this fashion. So this is your, suppose this is your 2 volt. Okay, 2 volt means 2 volt is going to happen at the positive terminal. So 2 volt is at positive terminal. So here 2 volt is there. Okay, so your now the voltage is 2 volt and the input voltage is below 1.6. you can see that the input voltage is below 1.6. so it will below 1.6 at this point. At this point what happens, input voltage again crosses the 2 volt, line. Okay, so what happens, as the input voltage crosses the 2 volt line, then input is given to negative. So this negative voltage is higher than this positive voltage, so output will again switches back to, so this output will again switches back to minus 4 volt or the minus B saturation. This is plus B saturation and this is minus B saturation. Minus B saturation is minus 4 volt. Okay, so this thing is going to happen again and again. Hope you understand this, that initially it is going to make a loop, and this loop is quite visible in the transfer characteristics. We will discuss the transfer characteristics also, but first you initially you just understand this, that this is a loop, and initially this voltage is 0, as this voltage, I am just repeating all this, initially this voltage is 0, as this voltage is 0, output will be, so this point potential will be higher than this point potential, so output will be minus V set. So this is minus V set. So how long this minus V set voltage is going to sustain, that we will calculate. As this voltage is minus 4, so X will change to minus 1.6, X will change to minus 1.6. So as long as your input voltage is higher than 1.6, it will maintain minus V. So as long as input voltage goes below 1.6, then what happens, this plus V set voltage will be higher than this plus potential, plus terminal voltage will be higher than negative terminal voltage. Then what happens, output will switches back to plus 5, so that is plus 5. So how long this plus 5 will be maintained, this plus 5 will be maintained as long as, so as this output is going back to plus 5, then what happens, there is a reference point, that means the potential at point X will again become plus 2 volt. Okay, so this is become plus 2 volt. As long as your output is plus 5, this reference potential, that means the X point potential is become plus 2 volt. So as this become plus 2 volt, so how long as this line will be sustained, so this input is below 1.6 volt, so as the input is going up 1.6 volt, sorry, plus 2 volt, then it will change itself. Okay, so input is going to change, increasing from minus 1.6 volt towards 2 volts. So as the input is crossing the plus 2 volt line, then what happens, plus 2 volt line, input is crossing the plus 2 volt line, that means the negative potential will be higher than this positive potential. Okay, so what happens, output will again switches back to this potential. So this thing is going to repeat again and again, it will become a loop, and that loop will be visible in your transfer characteristics. Now what will be your transfer characteristics will look like, I have already said previously that the transfer characteristics is a plot between your input voltage and your output voltage. Okay, so if you just plot the transfer characteristics, first you understand the circuit operation, then only you can know the transfer characteristics. Okay, so this transfer characteristics, 1 minute. So your transfer characteristics will look like, so this is a plot between the output voltage and the input voltage. So that is your output voltage and that is your input voltage. So input voltage range is plus 10 to minus 10 and the output voltage range is plus 5 to minus 5. So input voltage range is your plus 10 and this is your minus 10, and the output voltage range is your plus 5 to minus 4. Okay, sorry, so this is your range, this is your minus 4 volt. So initially what happens, initially your output voltage is at minus 4 volt, initially your output voltage is at minus 4 volt. Okay, when input is going to increase, now the input is going to increase, so here is your, I am considering here is your 2 volt line, this is your 2 volt line and this is your minus 1.6 volt line. So what happens, this is your 2 volt line and this is your minus 1.6 volt line. Okay, this is the referent to potential that has been created. So okay, so what happens, initially your output is going to, 1 minute, your output is at minus 4 volt. Now the input is increasing, so at the input is increasing your input is going to increase in the positive terminal also and in the negative terminal also, whatever it may be. So the input is increase, suppose your input is going to increase, so input is going to increase, output is not change until and unless it will fall back to minus 1.6 volt, minus 1.6 volt, output is not going to change. So the input is going to change in this fashion, so input is going to change 10 volt, so output will change nothing, output will fix back to minus 4 volt, it will not change. So input is going to increase in that fashion. Next, what happens after going to 10 volt, input is going to decrease in this fashion. So the input is decreasing in this fashion. So as long as input is, what happens, input is going below 1.6 volt. When the input is going below 1.6 volt, then what happens, as long as input is goes below 1.6 volt, output will again switches to plus 5 volt. So output will switches to plus 5 volt. So the first input will increasing in that fashion, then the output will fixed as minus 4. So it will goes to 10 volt, then so it will goes to 10 volt, then it going to reduce. So it will going to reduce in that direction. So in going to reduce in that direction, as it crosses the minus 1.6 volt line in the input, then output will switches back to plus 5 volt. Okay, then what happens, input will going to reduce in that direction up to minus 10. So input will going to reduce in that direction, output will not change, output will be fixed at plus 5. Okay, then again it will going to increase input. So input is going to increase, in that direction. Now until and unless input is crosses the plus 2 volt line. So suppose input is crosses the plus 2 volt line, then what happens, output will be again switches back to minus 4 volt. Input is again going back to plus minus 4 volt. Then again it will be increasing in that direction, plus 10, and again it will be reducing in that direction. So you can see there is a closed path. So you can see there is a closed path is being formed. Okay, so I am just again and in this path you will not encounter in this book, because this is the first time happens, and after that it will not happen anywhere, it will be sustaining. So I am just again going to explain this. So first, output is at minus 4 volt, this is your minus 4 volt. Okay, so first initially output is at minus 4 volt, so this is your minus 4 volt line. So what happens, this is your input. So input is now going to increase. How this minus 4 volt is sustained? So input is going to increase, nothing will happen, it will goes to plus 10 volt line, nothing will happen, output will still remain minus 4 volt. Then input is going to reduce in that direction until and unless it crosses the minus 1.6 volt line. This is minus 1.6 volt. So until and unless it crosses the minus 1.6 volt line, then output will be fixed as minus 4. As long as it crosses the minus 1.6 volt line, output is switches back to plus 5 volt. So this is your plus 5 volt. Okay, so then input is going to reduce in that direction at the minus 10 volt, because input range is plus 10 to minus 10. Okay, so input will going to reduce in that direction up to minus 10, nothing will happen, output will be fixed as plus 5. Now the input is going to increase in that direction. Okay, and until and unless it crosses this is your 2 volt line. So as long as it crosses, until and unless it crosses this 2 volt line, output will be fixed as plus 5. As it crosses the plus 2 volt line, that what happens, output will again switches back to minus 4. So this is a closed path that has been formed. You can see I'm just marking this path. So this is the path. Okay, so this is the path. So you will encounter this path in every book. So this is a closed path. So this is a transfer characteristics that being formed. This is a lock, output is being locked. Okay, and output is you can see that the output is going to form in this case, it is a square wave. So this is all about the Schmitt trigger. Just focus on the working of this Schmitt trigger, that means how this output transfer characteristics will look like, and how it is formed, and the whole operation. Okay, thank you.